This is the video for section 1.1.1, how do we measure velocity? A theme that is going to be continually revisited throughout the semester is the notion of a rate of change. And in fact, one could say that differential calculus, which is Calc 1, is all about rates of change. And so the first example of a rate of change that you may have seen in your life or that you are no doubt familiar with is that of velocity. And so a question is, how do we measure different types of velocity? And in particular for us, there's going to be two types of velocity that we will consider. We'll consider average velocity and we'll consider instantaneous velocity. And these, for our purposes, are going to be two different quantities, and they're going to be computed differently, and they're going to be geometrically different, although they will be intimately related, as we will come to see here in the first few sections of the class. So what do I mean by average versus instantaneous velocity? Well, let's first give ourselves a little bit of notation. So let's let s of t be a position function. So it means s at time t is telling me a position. And I want this to be a function on the interval a,b. So this may be notation that you're unfamiliar with, but this is notation you will need to learn for this class. By when I have hard brackets, a comma b, that is just equivalent to saying a less than or equal to t less than or equal to b. So if I have a position function on that interval, then blank is the notation for the position at time b, and other blank is the position at time a. Take a minute, fill in those blanks, and what you should have come up with is s of b tells me the position at time b, and s of a tells me the position at time a. And let's just see what that would look like on a graph. So here my green curve is a position curve, s of t. I have time t equals a and t equals b. Where is s of a going to be located on the graph? Oh yeah, it's the y-coordinate of my position function and at time t equals a. And where is s of b going to be located on the graph? Oh yeah, it's the y-coordinate of my position function at time t equals b. So geometrically, that is what those 2 points mean. So we can use that notation to define what we mean by the average velocity on the interval AB. Now you may just think for a minute, what should the definition be? What should it mean to have the average velocity on an interval? Well, the average velocity is probably going to be my change in position divided by change in time. If you think of the old expression, distance equals rate times time, what we're really talking about there is average velocity, is what we mean by rate there. So the change in distance divided by the change in time should be my average velocity. And let's think about how to write that mathematically. So the notation we're going to use is AV for average velocity sub the interval from A to B. So we'll include that notation in our notation for average velocity. And it is S of B minus S of A divided by B minus A. And that is exactly our change in distance, S of B minus S of A, over our change in time, B minus A. So two things that you must notice about this definition. First of all, this is assuming that B is not equal to A. Why? If B is equal to A, notice that's a divide by 0. That is no good. Nothing good can come of dividing by 0. So we have to explicitly say that A is not equal to B. The other thing to notice here is that this is a quantity with units. In particular, the units are going to be whatever my unit of distance was in my position function divided by whatever my unit of time was in my independent variable. So it could be something like meters per second, for example. Now let's contrast that to the instantaneous velocity. So instantaneous velocity means quite literally the velocity at an instant. So already you're seeing a difference between average velocity and instantaneous velocity because average velocity occurs over a whole interval. So the instantaneous velocity at the instant when t equals a is the average velocity calculated on smaller and smaller intervals centered at A. Of course. What? You might be having the reaction, what the heck does that mean? Calculated on smaller and smaller intervals centered at A? How small is small? When do I stop? How do I know? What does centered at A mean? These are all good questions. Right now, this is a deliberately vague definition, and the subject of the first part of the semester, the first topic in the semester, which is something called a limit, is going to get at a less vague answer to this definition. But this is just something for you to start thinking about the difference between instantaneous and average velocity.